Balancing chemical equations is very important. It has to obey the law of conservation of mass, which says that we can't create or destroy matter. We merely change the way that it's linked up, change the way that it looks, change its chemical properties. So in this example, we have nitrogen reacting with hydrogen to produce ammonia. And we know why we have the 2 and the 2 and the 3 here, because nitrogen is covalently bonded. Hydrogen is also covalently bonded, and ammonia is covalently bonded as well. Now it's very important that we don't forget about our bonding, because these formulas represent the way they're actually bonded, and they're bonded in order to satisfy the octet and become stable and all that stuff we just did on our last test. So you can never ever change the subscripts. Now that being said, we can change the larger numbers, and the larger numbers are called coefficients, and that's simply accounting. I can have more than one nitrogen molecule, that's no problem. I can have more than one hydrogen or ammonia, that's no problem at all. So the way that we balance, I like to do this, is I write down all of the different atoms. So I have an N atom and an H atom, and on this side I have an N atom and an H atom. And then I count them on the reactant side and the product side. Remember, these are the products. They're produced by the reaction, and these guys are the reactants because they react together. So reactants and products, and I just count. I have 2 nitrogens and I have 2 hydrogens on this side, and over here I have 1 nitrogen and I have 3 hydrogens, and that simply can't happen. I can't start with 2 and have 1 disappear somewhere. Now when you follow these things, the rules that I like to follow are you always leave oxygen last and hydrogen second last, and if you have a polyatomic ion that's on both sides, you can balance that. Well, there's no polyatomic ions, these are covalent, but there is hydrogen, and I'm going to leave that to last. So let's start with nitrogen. If 2 went in, 2 have to come out. Now I can't write a 2 here because that's not how ammonia is, but I could write a 2 right there. 2 NH3s, which means I have an NH3 and an NH3. That's what that big 2 means. So I have 2 nitrogens. And now I don't have 3, I have 3 plus 3 is 6 hydrogens. And the nitrogens are all balanced out, but as we can see, hydrogen is not. So I'll go back to this side. I can't just produce 6 hydrogens if I only start with 2. I had to start with 6 in the first place, and the way that I can do this in groups of 2 are 3 groups of 2. I can have 3 hydrogens, 2, 4, 6. So 3 hydrogens, 1, 2, 3. 3 hydrogens can produce the 2 ammonias right there, and so this ends up being balanced. 1 nitrogen plus 3 hydrogens makes 2 ammonias, and now both sides, the reactants and the products, are balanced. And I know I'm balanced when all of those numbers work out. In this example, we have ionic bonding, and ionic bonding, as we know, is with ions, so this would be an Na plus and a Cl minus. This is covalent. F2 would be bonded covalently, producing an ionic compound, Na plus and F minus, and another covalent bonded here, Cl2. So we kind of have some mixed things going on here, but that doesn't matter. It doesn't matter what the reaction is. We just care about the atoms and that there's the same number. So I'm going to do the same thing. These are the reactants that react together, and these are the products that are produced at the end. And I have an Na right here, I have a Cl right there, and I have an F. And checking this side, I have an Na, good, an F, good, and a Cl, good. So I'm just going to put those down the middle, and this is how many I have on each side. So on this side I have 1 Na and 1 Cl and 2 fluorines. This side I have 1 Na, 1 F, and 2 Cl's. And at quick glance I can see that these are not balanced. I don't have the same number on each side. Quick review, always do oxygen last, hydrogen second last, and if you have polyatomic ions you can move them together. We don't have any of those, so you can balance this however you want. I'm simply going to go in the order we have them. Chlorine is first up, so there's 1 on this side and 2 on that side. I can't make 1 out of nothing, so there had to be 2 at the beginning, and that makes this into a 2. But that doesn't mean there's 2 Cl's. It means there's 2 NaCl's. It means that there are 2 whole ionic compounds. So that means I also have 2 sodium. So in this case, while I helped my chlorine become more balanced, I didn't help sodium. And again, I could do sodium or fluorine, it doesn't matter. I'm just going to stick here because that's the one that's first up. 2 went in, 2 had to come out, and the only way they come out here is sodium fluoride. So 2 sodium fluorides must come out. That means 2 NaFs. So I have 1, 2 sodiums now, which is good, but I also have 1, 2 fluorines. And in this case, that's pretty happy for me because I had 2 going in and now I have 2 coming out, and I notice that I have everything balanced, 2, 2, 2, 2, 2, 2. So the balanced chemical reaction here must be 2 sodium chlorides plus 1 fluorine makes 2 sodium fluorides and 1 chlorine molecule. In this example, we have all ionic compounds. We have aluminum bromide and potassium sulfate react together to produce potassium bromide and aluminum sulfate. Now here it's really important that you recognize that SO4 and SO4 here in the brackets are the same. They're a group. It's SO4 2-. It's what we call a polyatomic ion. And as long as they stay together on both sides, they travel as a group. So I don't need to balance an S and an O separately. I can just balance an SO4 group here and an SO4 group there. And that's going to help us out. So knowing your polyatomic ions is really important. So remember, we have our reactants and our products. Al is right there, followed by a Br, a bromine. We have a potassium, and we have the sulfate group. So instead of writing S and O separate, I'm going to write SO4 as a whole group here. And that's going to be the same on this side. K and Br, Al, and SO4 group. So we're good. So my reactant side and my product side, I'm just going to count them up. I think I like red better. Let's go back to red. Al, we have 1. Br, we have 3. K, we have 2. SO4 groups, I have 1 SO4 group. On the product side, I have 1 potassium and 1 bromine. I have 2 aluminums, and I have 3 groups of SO4. 3 groups. Well, clearly all my numbers are not balanced, so again, following the rules, oxygen last, hydrogen second last, and balancing polyatomics together, we're going to follow that. Now, other than that, you can go in any order you want. I'm going to start left to right because that's the way that I like to do it. Aluminum over here, there's 1, but 2 came out. The only way that's possible is if I start with 2. I didn't create an aluminum out of nothing. I had to start with it, which means I have 2 aluminum. But of course, I don't have just aluminum. I have bromines too. So 2 AlBr3s, that's what that big 2 means, gives me 2 aluminums, 1, 2, but 3 plus 3 gives me 6 bromines. So don't forget, just because I'm balancing aluminum doesn't mean that I can forget about bromine. Okay, aluminum's balanced, but bromine's not, and bromine's still here on the left, so I'm going to go with that. If 6 bromine were here, 6 bromine had to come out. I can't change this number here. I can't change this bromine. I have to say that I have 6 potassium bromides because that's where it went, which is good because that makes 6 here, but it also makes 6 potassiums. So there we are. So now my first 2 are balanced. I'm going to keep going left to right. Potassium is next. 2 were there at the beginning, but 6 are there at the end. That's not possible. I had to start with 6. Well, the only way that I can start with 6 if they're groups of 2s is to make 3 of these. 3 potassium sulfates. 3 times 2 is 6. Give me the 6 potassium that I need. But I also have sulfates here, so 3 times this imaginary brackets, 3 times that group means I have 3 groups. 3 groups here. And that's good because I made 3 groups there. So now if I look, I'm balanced. 2 and 2, 6 and 6, 6 and 6, 3 and 3. So my balanced equation here is 2 aluminum bromides plus 3 potassium sulfates make 6 potassium bromides and 1 aluminum sulfate. Final example for this balancing work that we're doing. This one here is an interesting one. Anytime you have oxygen by itself, it's usually something burning. In this case, this is methane gas. It's what comes out of your Bunsen burner. It's what powers most of your furnaces. So they're doing this combustion. And these ones can be tricky. So I like to follow the rule that you always balance oxygen last because it's by itself. Hydrogen second last, and then we go from the rest. So in this one here, we're definitely going to leave the oxygen till the end, and hopefully by the time the others are balanced, we can just put one number here and finish it. So again, reactants and products, I have carbons and hydrogens and oxygens. Carbon, hydrogen, and oxygen. I have carbon, oxygen, and hydrogen on this side, so I have reactants and I have products. Now, the reason you want oxygen last is twofold. One, it's by itself, so hopefully at the end I can write one number here to balance out, and the other reason is it's going in two different spots. So every time I change these numbers, it's going to change the number of oxygens. So let's leave it till the end. So let's start with carbon. I had one carbon go in, I have 4 hydrogens, and I have 2 oxygens. Coming out, I have 1 carbon, 2 oxygens here, plus 1 oxygen there is 3 oxygens, and 2 hydrogens here. So starting with carbon, 1 went in, 1 came out. That's pretty good. So I'll move over. Hydrogen next. 4 went in, but 2 came out. That's not possible. So the only way that I can do that, have 4, is if I have 2 H2Os, which would look like this. That's what that means. 2 H2Os has 2 plus 2 is 4 hydrogens, but it has 1 plus 2 oxygens, plus the 2 over here means that this now goes up to 4. Okay, so 1 carbon went in, 1 carbon went out, 4 hydrogens went in, 4 hydrogens came out, 2 oxygen went in, but 4 came out. That's not possible. And if I have 2 groups of O2, so if I have like that, 2 plus 2 is 4, how do I represent that? With a big coefficient. 2 oxygens means there's 4 O atoms. 4 went in, 4 came out. We have a balanced chemical equation. So by doing oxygen last, I only had to change the number here, which finished it.